Let us understand the arrangement of first order pulley system with the help of diagram. We have used one fixed pulley and three movable pulleys. We will give numbers to these pulleys. So fixed pulley will be pulley number 1. Then this is second movable pulley, this is third, and this is fourth movable pulley. Now effort is applied to the rope which is provided at the fixed pulley. So I will show here effort which is applied at the fixed pulley, and it is known as Fe. Then load provided at the last pulley, that is the fourth pulley. So we will provide here load, and that is known as Fw. So total load is Fl, F to the base L. So we can say that applied effort Fe to lift the load Fl. Now how to arrange all these pulley with first order pulley system. Now in this diagram, number of fixed pulleys, that is equal to 1. And when we use the first order pulley system, then number of movable pulleys is equal to number of ropes. Now here 1, 2, 3, 3 number of movable pulleys. That means we have to use 3 number of ropes. Now how to arrange this? So we know that this fixed pulley is fixed at the support which is provided at the top. Now this is the rope number 1 which we have to arrange with this fixed pulley and with this movable pulley. So how to arrange this rope number 1? Because at rope 1 we have to apply the effort Fe. So we have to pass this rope over the fixed pulley as well as this movable pulley. So I will show here this rope is passed over the pulley number 1. Now again it is passed through the pulley number 2. And now this rope number 1 is fixed, that is other end of the rope number 1 is fixed to the support at the top. So I will say that this is the rope 1. Now we will move to the rope 2. Now we have to again connect this pulley 2 as well as pulley 3. So how to connect? So at this middle point of this pulley 2 we have to connect other end, or we have to tie the one end of the rope, and again it is passed or suspended over this pulley 3. So I will use the second rope. So here we have to tie the one end, then it is passed over this pulley 3, and then we have to fix this rope number 2 to the support at the top. Now we will connect this pulley number 3 and pulley number 4. So again I will tie one end of the rope to the middle of this pulley number 3. We have to pass this rope 3 over the pulley 4, and again we have to connect this rope at the support of this top. So this is the top support. So this is the rope number 3. Now if we observe, there is one fixed pulley, there are 3 movable pulleys, and there are 3 number of ropes which are tied at the support of the top. Now here is the load Fl. Now this load Fl will try to move in the downward direction. So I will show the direction of movement of this load Fl. So what will happen? So tension is created in the rope which is passed over this pulley 4. But there are 2 number of ropes, that is on the right hand side as well as left hand side. So this total load Fl will be divided into 2 parts, that is Fl by 2. So the tension is created in the opposite direction, that is in the upward direction in the rope, and this tension is equal to Fl by 2 on both sides. So I will write here Fl by 2 and here also Fl by 2. Now what will happen? This same rope is tied tension created nearby to pulley 3 in the opposite direction. So this tension which is also equal to FL by 2. Now if we observe, this pulley 3 is also connected to the rope at the two sides, that is on the right hand side and at left hand side. So this tension created, now this FL by 2 related to pulley number 3 is in downward direction. So we can say that tension created is in the upward direction. So I will show here direction. And this tension created on both sides. So we have to divide this FL by 2 into two equal parts. That is half multiplied by FL by 2. So we will write here FL by 4. FL by 4 and FL by 4. Now this FL by 4, that is this total tension, is attached to the pulley number 2, which is movable. So this pulley is also movable. So we can say that this tension is created nearby to pulley number 2 is in the opposite direction. So I will say here it is equal to FL by 4. Now this FL by 4 again carried out by the two ends of the rope. So here the tension is created. Now FL by 4 is having downward direction. So tension created in the opposite direction. So it is again, we have to divide FL by 4 into two equal parts, that is half into FL by 4, that is FL by 8, and here also FL by 8. Now if we observe, here is the rope which is passed over the fixed pulley. Now this pulley is fixed, so this tension is carried as it is and which is equal to Fe. Because this is fixed pulley, so same tension is carried by this rope, that is equal to FL by 8. So we can say that here Fe is equal to FL by 8. So from this diagram, this effort is equal to FL by 8. Now what is the mechanical advantage? So we know that it is the ratio of FL by Fe. So FL by Fe is equal to, so if we observe FL and if I take Fe to the denominator, then which is equal to 8. And how we can write this 8, which is also equal to 2 raised to 3. Now what is this 3? So we know that number of movable pulleys, that is equal to 3. So we can say that number of movable pulleys, that is equal to n. So we can write VR, that is velocity ratio, which is equal to mechanical advantage, is equal to 2 raised to n. Now this is the formula that we have to apply for ideal machine. So for the ideal machine, we know velocity ratio is equal to mechanical advantage, and which is equal to 2 raised to n, that is equal to number of movable pulleys is equal to n. So this is the formula to calculate velocity ratio or mechanical advantage in case of first order pulley system.
Given question, for the first order system of pulleys with 3 movable pulleys, what is the effort required to raise a load of 6000 Newton? Assume efficiency of the system to be 80%. If the same load is to be raised through 519.9 Newton, find the number of movable pulleys that are necessary. Assume a reduction of efficiency of 5% for each additional pulley used in the system.
Let us understand given data. Number of movable pulleys n is equal to 3. Load FL is equal to 6000 Newton. Then efficiency is 80% and we have to find out applied effort Fe. Now here efficiency is given 80%. So for ideal machine we have seen that efficiency is 100%, and in that case mechanical advantage is equal to velocity ratio. But in this case efficiency neta is given 80% and it is the ratio of mechanical advantage to the velocity ratio. So here we have to find out VR. So we will calculate this VR with the help of this n is equal to 3. So we have formula for first order pulley system. VR is equal to 2 raised to n, that is 2 raised to 3 is equal to 8. Now we will put neta 80%, that is 80 by 100, and which is equal to 0.8 is equal to MA by 8. So mechanical advantage, that is nothing but the ratio of FL by FE. So FL by FE is equal to 0.8 multiplied by 8. So value of FL is given, so FE is equal to 937.5 Newton. In first case, total number of movable pulleys are mentioned, N is equal to 3, and efficiency is also mentioned, neta is equal to 80%. Now we will move to the second case. In second case, applied effort FE is mentioned 519.9 Newton. Now we have to find out the number of additional pulleys, that is the number of additional movable pulleys. So we will consider this N1 is the number of additional pulleys, and which is equal to N minus 3, because in previous case 3 pulleys are already exist. So suppose N1 is equal to 1. Suppose we add 1 additional pulley, then what is the value of N? N is equal to 4, because we can say that 1 is equal to 4 minus 3. In case of 2 number of additional pulleys, that is when additional pulleys is equal to 3, then here total number of movable pulleys in the system is equal to 5, because 2 is equal to 5 minus 3. Now when we add any pulley, then what is the condition given? So this condition is related to efficiency neta. For any additional pulley, this efficiency is reduced by 5%. That is, when we add one number of pulley, efficiency is reduced by 5%, that is 0.05 times. Suppose we add 2 pulleys, then it is reduced by again 5%. So we have to multiply with this N1. So how we can write the new efficiency with this condition? So new efficiency neta 1 is equal to 80%, that is 0.8 minus in the bracket N1 into 0.05. Now we will put the value of N1. So N1 in terms of N, that is N minus 3. So 0.8 minus in the bracket N minus 3 into 0.05. So we will simplify this. 0.8 minus 0.05 N minus 0.15. So N1 is equal to 0.65 minus 0.05 N. So this is the final value of neta 1. Now we will write the formula for this new efficiency. So we know that efficiency is equal to mechanical advantage by velocity ratio. So for mechanical advantage, it is the ratio of FL by FE, that is this load divided by effort. And for the second case, effort is mentioned 519.9 Newton. And then VR. So for this velocity ratio, we have formula 2 raised to n for the first order pulley system. So we will put this value. So we have efficiency in terms of n. Here is also VR is equal to 2 raised to n, and we have to find out FL, because we have given the condition that for the same load, that is for 6000 Newton load, if we apply effort 519.9 Newton, then how many number of pulleys should be in the system? So we have to find out the value of N. For the value of FL is equal to 6000 Newton. Now instead of putting here 6000 Newton, we will take N is equal to 4, because in previous case N is equal to 3, so we will add only one number of additional pulley. So when we put N is equal to 4, then when we put here N is equal to 4 and here is also 4, then what is the value of Fn? So this Fn is equal to 6240 Newton. That means when we take the 4 number of pulleys, that is the 4 number of movable pulleys in the system, then it can easily lift the load 6240 Newton. And what is our load? That is equal to 6000 Newton. So we can say that for the applied effort 519.9 Newton, we have to take the 4 number of movable pulleys in the system.